Alright, so in this problem, we got a problem where we're modeling the student population at Brian McMahon High School from 2006. It looks like it goes 5 years, so that would be through 2010 or 2011, yeah. So there's actually 6 points, right? Yeah. Okay, so here is our scatter plot, here's our residual, here's our regression output. Okay, so is the linear model appropriate? So what tells you if that's appropriate? Okay, so is it appropriate? Well, the scatter plot is straight enough. And the residual plot is random. So secondly, how strong is the model? Okay, so in this case we know that r squared is 76.8%. So to get r, we got to do the square root of 0.768, which is 0.876. Now, one other thing you got to take into account here is that the direction of this is negative. Okay, so r is negative 0.876, which means that it is a negative strong linear association. Okay, negative strong linear association between student population and time. R squared is 76.8%, which means 76.8% of the variation in student population is accounted for by the linear relationship with time. Now write the least squares regression line. Okay, so next to constant is your y-intercept. Your b sub 1, your slope is right there. Okay, we know that the dependent variable is student population, so predicted student population equals the y-intercept minus 37.6 times years since 2006. Okay, we got to put that in there because of this statement right here.
Peter Mashak to the main office. Peter Mashak to the main office.
Okay, so next we got to explain the following in context. What does the y-intercept mean? Well, the y-intercept in this case, the 1696, is the predicted amount in the year 2006. So in the year 2006, we predicted there'll be 1,696 students. It's not an extrapolation because your zero here is 2006, so that's okay. We don't have to put anything after it. The slope, go ahead and write what the slope is.
Attention students, will Olivia Bagos, Dennis Dennerville, please report to guidance. Olivia Bagos and Dennis Dennerville to guidance, please.
So the slope is the student population at BMHS is decreasing by about 37.6 students per year. Okay, another way you could write it is each year increases, the student population of Brian McMahon will go down by about 37.6. Okay, we've already done R. We did it up here. We already did R squared. We did it right there, so you don't need to do those. And then in the year 2007, there were 1,635 BMH students. Calculate and interpret the residual. So go ahead and do that, please. Okay, so what we're going to do is we're going to put 1 year into our model, okay, because year 0 is 2006, so year 1 would be 2007. So that's the predicted amount, 1658.4. So if we do 1696 minus 37.6 times 1, we get 1658.4, and then we're going to do actual. Okay, so 1635 minus predicted, and if we do that, we get negative 23.4. So what does that mean? Well, it means there were approximately 23 less students at BMHS in 2007 than predicted by the model. That's all that means. Okay?